So
but these also any specific model
generated model also is there. So what the tutorials what they say is like you just look at the nameplate of the mode of your DE system and then you just directly can enter it. So then it will simulate that. So that is how it is. So and what we will do now is the basic features and introduction to using Python. So we will not cover circuit analysis and advanced, we will not cover only the basics. So basic OpenDSS is snapshot and time series. So snapshot is one time solving it. Time series is like over a period of time. Like I'll show you. And what we don't cover is harmonic, stability, fault analysis. Don't cover it, but all those things are available. Tutorials are available and you can look at. So, so here are some links and you see here like so this manual framework, the PDF I already downloaded and given it, so you can directly, we'll go to that also, we'll go to that. And there are two training PDFs also, which also given the PDFs. And then there are a lot of online documentation and there's a video which we will watch. And then so there are other tutorials on YouTube and then Python 2 libraries which we will use. So this is what place where you download and install and Python we will see later. So if you have Python, we can look at it. Otherwise, I'll show you how and then we can see it. So now what we will do is I will go through, we watch the video, which is the overview video. So the link was there in the other one. So this is a very quick fast overview video and you don't even need to have audio, like there is kind of self-explanatory and this small video touches the most of the basic aspects of OpenDSS. Okay. So
hello, my name is Celso. In this tutorial video, I'd like to give you an overview about some things that we support simulations called OpenDSS. This is OpenDSS mainly. I've opened the IEEE 37 buses circuit diagram, which can be found in the folder IEEE test cases in OpenDSS. This is the script that describes the circuit. And it starts with all circuit element definitions and solve. There is an element called circuit. There are also some transformers, lines, regulators, and loops. In the video called tutorial overview, we will show which of these elements will be presented in this first result. Now, let's run the script and take a look at what kind of result you can easily get from DSCE. Begin with by using the command 2. There are different ways to use this command. One of them is by selecting all the scripts and pressing Ctrl D. As you can see here at the bottom of the menu, the script has been successfully solved. Another option is by clicking the blue tab and select Light. Finally, if you select all the script, right-click and press
this is an introduction. We will do the same thing. Just watch.
Let me show you some useful features of this software. For example, you can plot your secret through the plot tab. Here is our secret. The figure, you can select any line that you wish. These numbers here show the names of the buses which the line is connected to, and also the nodes in each bus. After you select a line, you can right-click. You can access some information about the selected line. Let's take a look at the values. Here we can see the line's name and the names of the buses again. We can also see some data like the port code. aligned to the voltage with total losses, for example. Now, let's explore the tab show. If you go to voltage and then line structure rules, a report showing the line structure movement of all loads of the system will pop up. Looking at the bus 799, notice that the voltage of each phase has a different value than the others. The reason being is because OpenDSS can handle unbalanced systems, which is a quite important in distribution system analysis. You can also get reports for currents and powers as well. There's another way of seeing voltage, currents, and power in an element that is using the visualized value. All you have to do is to choose an element. Let's choose a power related element. There will be a line, and then a random line. Now, if you go to visualize, choose either from voltage, currents, or power. Let's show the voltage in the line L13, for example. You can access other reports on show tab like buses, energy curve, event log, and losses. Let's plot the system's voltage profile. In order to do it, we must define an element called energy, which will describe in detail later on the sequence of input outputs. We'll place it in the first terminal of the substation bus forward. If you add the command plot profile and run all the scripts again, we should get a voltage profile like this. It shows two curves, one for each phase and also the maximum and minimum curves over its voltages, which by default are 1.05 and 0.95. If you click on the curves, you can select a line, and by right-clicking, you can access some information about the line, pretty much the same as we did in the circuit. Depending on the changes that we do in our script, you don't need to run it all again. For example, let's say that we want to plot the circuit showing some elements. This would be the performance button. In this case, as we have already loaded all the circuit elements in OpenDSS with the script the first time, all we have to do is to add a command that farms transformers, run it, and then command plot circuit again. As you can see, the red marks are showing us the position of the transformers. What we have done so far was to solve the circuit using the snapshot simulation. An important feature of OpenDSS is that it performs sequential multiple simulations. So let me comment these three lines here and add a development to perform a time series. As you can see, I've added a load shape of 24 values to describe how the load vary in one day, and also set resolution mode today with a step size of 1 hour and 24 points. Let's run the script and plot, for example, the load shape 1 that we have defined for all the loads. As you can see, it's defined for a period of 24 hours. We can plot variables like active power for each phase. Reactive power, and finally, line to the locomotive. Now, we will certainly be system integrity. We have prepared these three files here that describe the PV system. One of them is a DSS file, the other two are CSV files. Let's take a look at the DSS one. It basically describes our PV system, including its characteristics such as power versus temperature, efficiency, irradiation, and temperature curves. These last two are important in the CSV files. We will copy them to the folder where the Itron flow 37 process feeds is placed, and we will add a comment here to make sure that these files will be followed by OpenDSS when we execute. Now, let's change the step size and the number of points to have 1 day of simulation with the resolution of 1 second, and finally, execute. Plotting the irradiation curve, you can see that it has huge changes in all time intervals, as we can better see applying. These changes accounts for shading, for example. We can also check the active power injected to the grid by the PV system, and as you can see, it also has rapid oscillations in accordance to the irradiation curve. Another major feature included in OpenDSS is the possibility to be controlled by Microsoft via Microsoft own interface. You can use MATLAB, VBA, Excel, and Python programs. Here I have a script file that controls OpenDSS to contain all the 24 individual files. Another useful tool is to create an interface for OpenDSS. Here I have an example that's to show the simulation result. I choose a DSS file which has an solution network, and I can place some bar that the system objects inside. I can also select the simulation and curves for the loads in the distribution of the solid. So in for this setting, we can plot the voltage unit bar and see the left window. And for example, we can choose a specific time and plot the grid profile at a specific time. This is just an example of what kind of things you can do in the common interface. The key idea is that by controlling OpenDSS interface, you can do everything you can do using the standalone version and much more, according to your own application.
Yeah, so that was a quick overview of functionality. So they took IEEE 35 node circuit. So what we will do is a very simple circuit in just one line to start with. So this is that video which you saw is, the link is here, this basic tutorial from BRI chapter overview. So this is what the video which I showed you. So this is a video which we saw. So now documents, there are this PDF files which already I given you. So so this is the manual, the user manual, and this is one version which is available, but they have made some changes, but most of it will be valid. This is a primer, like just the basic ones. And then these are very good tutorials. Okay. So let's go and show you this one first. Okay. So I'll just walk you through it quickly, but then later you can go through it in detail. So this is just to show you what documents are available, okay, and what it is capable of doing. So earlier it was developed and the EBRI bought it and then made it available for free. But so yeah. So these are all some things which are possible by it. Okay. This kind of graphs you can do. And so this is the kind of plots like if you, so two things. One is when you want to first try out the system, you will be using all these graphics, right? Like, but then when you want to do serious research, you will be writing scripts because you will be getting tons of data which you will have to put it in an Excel or put some in doing some analysis using either Python or I don't know, SPSS you use here. Like what do you use for data analysis here? Python and then like Excel. So you'll be putting it, then you'll be analyzing it. So everywhere you can ask it to export the data into CSV format. It will export it, which you can use it for your further research. Okay. Whereas if you want to just see, okay, how initially when you want to do some pilot, you want to see, okay, whether it is working, how is it, you can use the UI. So the UI is not very good. It's not like a very modern UI because the purpose of the UI is only for you to just get the program on the basics, but most of what the work which you will be doing, serious work, will be you'll be exporting as CSV files. So it doesn't matter if the UI is not so good. UI is not good, but it is okay, right? So this is how, like, if there's a line. So you have the three-phase line. What are the ABC phases? What is the like input and output? So this is how it shows. Right? So angles, like if it is polar coordinates, like it will give the magnitude and the angle like this. And yeah, so these are some of the examples that is there, and installation. Yeah, so to understand how exactly it works, so basically like they are given some amount of documentation. So now this is important. Like, so what are all available? Now you have what is called as a circuit, and then you have what is the solution is there, and then there are this power delivery elements and power control elements. So PD and PC. So PDs are like line, transformer, capacitor, reactor, right? So basically which has two sides. So whatever has got two sides, input side and output side, that is the power delivery element. And then PC is control element where it's only one sided, like load or generator, voltage source, current source. So these are the PC elements. And then you have control elements like regulators, capacitors, relay, reclosure, fuse, these are available. And then monitoring elements. So monitor, energy meter, sensor. So basically monitoring elements mainly like because voltage you can always get for anywhere. Monitoring will keep over a period of time. We will see how to use monitors. And then there are general this thing like which is line codes, line geometry, wire data, load shape. So this is like suppose if you say line code, it will be you can mention for what is the impedance per meter of the wire, and then you can do right? So those kind of there's line codes, and then wire I'm not used to wire data, line geometry, and load shape is over a period of time how the load changes, and so those kind of things you can mention. Okay. And yeah, this is the class structure which they have given. There is again the list of DSS classes. And what are the principles? So basically, like you have terminals. These are called terminals, and then this is as we go we will see. So you have multiple phases. So you will have this kind of. So when we go for the actual definition, we will see. Like I'm just browsing through it. Don't worry if you don't fully understand. It's okay. Like I just as we keep going, you will be able to understand better and better. Okay. So this is a typical PD element. You will have terminal 1, terminal 2, two sides, and it is modeled as I equal to Y into V. Right. So it's two matrices. So the matrix format is what it uses. And so basically what OpenDSS does is it creates every element is modeled as a matrix, right? I as an impedance as a conductance matrix, right? So I equal to Y into V. Admittance, yeah, the admittance matrix. And then using that it builds the whole matrix for the entire circuit as a sparse matrix, and then it uses the K-solve library to solve the entire matrix. So that is so it has two methods of solving. Like one is this what is called the normal method where it uses the K-solve. Other one is called Newton-Raphson. So you can choose either of them, and then it will do multiple iterations for convergence. So that is how it works. Okay. And yeah, so PC element would be one-sided. Like so you have and then a bus will basically will connect two elements, so you can define the buses how to connect. Okay. So these are the ways the circuit is defined. So if it comes to a transformer, so a transformer is defined, right? Like you have a transform. So the syntax is like if you have this exclamation character, it means it is a comment. Okay, and then if it is a tilde, this tilde character, it means it's a continuation of the previous line. Okay. And then, so you have a new transformer dot, you give the name of the transformer, number of phases, windings, right? So like this, so, and then you have various parameters. So the user manual will tell what exactly each one means. Common ones like buses, so you have the two sides of the transformer. And then bus 1 is one side, so what is that side, and bus 2. Now in this case, this is defining a transformer like this. So this is actually a typical US transformer. Yes. So you have this double winding transformer, like so where once the low voltage side, it gives 240 volts with the center tap, so that you have 120, 120, and then you have to, so this will be 180 degrees apart. So you can use 120 volt device also, you can use 240 volt devices also. So there is it is called a three wire single phase. Okay, there is only the US they use that. Okay, so it is basically two 120 volt circuits with 180 degrees phase shift. So you can line to line if you take, you will get a full proper 240 volt, or line to center tap if you take, you will get a 120 volt.
So depends upon the number of turns.
The turns will, these two will be equal number of turns, so that this is exactly 180 degrees apart, and it is, and the primary side of course, like you have. So now for this kind of a circuit, like so you have bus 1.1. So on the bus 1 there is only one phase, and that is connected to here, and then the bus 2 on this is the transformer, right? Connected to bus 1's phase 1, and then here on the secondary side, bus 2 and 1.0 and 0.2. So 1.0 is like 1 to 0, and then 0 to 2. So because it is 1, 0, 0, 2, automatically it is 180 degrees apart. Like if you put 1, 0, 2, 0, then it will be on the same phase. So if you want to put it this way, like you will put it. So this is how you define it. Okay, so of course this problem will not be there for our circuits here, but sometimes if you will, when you download some OpenDSS file, you will find this kind of a transformer. Okay, and then you mention what are the KVs, right? Like so 7.2 kV on, so you have 3 buses, 1, 2, 3. So each bus you mention what is the KV. So this side is 7.2, and then 0.1 to 0.12. So 120 volts, 120 volts basically. And then what is the KVA? KVA is the same, like 25, 25, 25 therefore. And percentage R's, like, so basically like the losses and all those things will be there, and it is a Y all sides. So if you have a delta Y, then you have to say delta and then Y, like, so you can mention. So okay, and then so this is three-phase transformer, like and it's a delta Y three-phase transformer, right? Like, so this side is a delta, this side is a Y. So you can define those kind of things. So again, they give the model of a PC element and a three-phase Y connector. Okay, so this is how the whole thing works. Like, so you have the matrix and it solves the matrix. By matrix solving it works. Okay. And so this, from this onward, like we will try it out. So this one I have actually put it into the tutorial. So this is the basic. Okay, so as you saw, we have elements. So this is a typical basic script, right? And this circuit we will do it. First we can go through it and then we can try it out. So you define a circuit, and so by default it will create a voltage source, and then you can mention what is the voltage source. You give the base kV and the per unit multiplication, right? And then ISC one, like, okay, I forgot what is it. It's basically
short circuit current.
Short circuit currents, yeah. Okay. So you mention those, and then after that you give the transformer definitions, right? What are the buses? If you see here, now this side, so this transformer, so this side the source bus is there, right? It should be there. Yeah. Right. So this source bus is there, and then you have the sub bus, right? So that is what is meant. So source bus, sub bus, and then what are the connections? So this side is a delta, that side is a Y, and then what are the kilovolts, right? So kVs, it is 115 kV this side and 12.47 kV this side, and then the kV is 20 kVA, 20,000 kVA.
kV is same.
Yeah, is the same, and then XXL, I don't remember what it is, like reactance.
So all reactance.
Yeah. So these are some of the parameters. Like if you go to the user manual, you can find a full list you can use so many parameters for defining transformers. Right? So you can model it pretty well actually. And then line code. So basically this line is there. So for that line, what is the matrix? So basically the entire matrix of that line you mentioned here. And then what is the unit? This is kilo feet, right? So for every 1,000 feet, this is the impedance matrix. And then you can define, this is the line code. So where you are giving the model for the lines. And then after that you define lines. So now this line we define, say okay, what are the two buses? Bus 1, what is this side, and bus 2. So here it is the source bus and here the load bus is there. So the sub bus and load bus, that is what is mentioned. This is the line code. So line code it is defined here, that line code. And what is the length? Like this is kilo feet. So here the length is given as 1 and it is in miles. So it will do all the conversion automatically, like multiple, what all units are supported is there, the user manual, right? Like meters, kilometers and everything, lot of things are there. And then you define the load. So the load here, so the load is connected to, the load's name is load 1. It is connected to the load bus here. And then it is 12.47 kilovolts and 1000 kilowatts and power factor of 0.95. So once you have put this, then you can say solve it, and then you can say show voltages, show currents. So it will solve this circuit and it will show. Okay. So this is the basic one, and so this tutorial explains everything, like what is the syntax, right, and what are the delimiters. So basically it gives how to what each one means. And then typically when you have a big project, this is how you organize the files. So you have a master.dss, and then you have line codes, wire data, geometry, spectrum, load shape, all these. And then you have the circuit definitions. So we will take some examples and we will go through it. So solution modes, like it has multiple modes. So for flow, short circuit calculations, and I didn't explore all of them. So mainly I have explored snapshot and time series. So that we will cover in this. So so in a time series also you can mention like daily, yearly, right? There are multiple ways. Okay, and you can also ask it to do some random simulations, like so Monte Carlo simulations, different one. So there are a lot of possibilities which are there. Okay, so snapshot mode, that is the default mode. You can we'll try it out. Okay, so then yeah, so we will. So you can go through this later, right? So and then you can have a time series mode. That's also we will try one time series mode also. Okay. So overall, like this is the kind of overview. Okay. And then it had so many other things. So let us today we will work like I will get only the snapshot and time series. Okay. So that we can try it out, but it has a lot more capabilities which you can explore later. So this is one training PDF. This is also already given to you, and then there is another one which is still more detailed one, and so this basically like is another tutorial where it takes one circuit and then it again it explains links to what is the user interface and go through the specification. Yeah, so how to define a circuit, and so the concept, everything is explained here. And then this one gives very detailed explanation of each of those like commands. And then so these are all the commands which are explained here. and after that it will take one sample and explain. So this is almost like the user manual, like all the properties, all the options for every command is shown. Okay. So you can go through it, and then like it takes a sample circuit and so ITP 13 node test feeder, it explains line by line how it is defined. Okay. So this is a second level tutorial which you can go through to be able to understand. So it has 3 use cases and to go through. So that tutorial you can go through it later. So what we will do now is, and then you have this manual which again has a detailed explanation of all the commands, what are all the options, everything. So which you basically you can, whenever you want to refer to something, you just go there, go to the manual, either this manual or this tutorial in cases. And then you can go and read, okay, what are the possibilities, what options are there, and then you can see. So these documents are all given to you, so I just want to just take you through the overview of the documents. So as I mentioned to you, so these are all the elements which are available in OpenDSS. Okay. And then, so let us go for, let us try out this circuit. Okay, so this circuit I already explained, right? So this is a, so you have all the PDF on your laptop, right? So that you can copy paste. You don't need to type in, right? So what you do is, so I forgot to bring pen drive, otherwise we have passed it around to the drive. No, everyone has the
I have
PDFs.
shared, it's there.
You have it on the laptop, right?
Yes, sir.
Okay, fine. So So what we do is, first you can try out first directly OpenDSS. Okay. So what you can do is you can just run OpenDSS. Okay. So you will so you will have, so you can run it and then you have this blank one, okay? And then we'll start from here. So you have the PDF open, right? So if you already do this, also open the PDF, so if there is any problems, that's exactly what and so along with that, the zip file is there. That zip file actually has the actual code also. So now in that zip file, you have a folder called snapshot, right? Yeah, or you can even try that. So you can just open the zip file. You can expand the zip file and view it. So now there you have these files, right? Master DSS, bus coords, and run, right? So that master DSS, like you can actually double click on master DSS. So I think it will open it in this one. Right? So that master.dss, if you open it, you can see the code, right? You're able to open it?
Just pasted.
Yeah, that's also fine. Yeah. So now what it does is first is clear, so it basically like resets all the simulator, everything, and then we are setting the default frequency, right? So okay, so we are setting the, so the instructions are here. So paste the code in OpenDSS UI and then select all the code using Control A, and then Control D will run the code. Right? So this is the basic operation. So if you go here and then you do a Control A, it will select. Then you do Control D. It will. You can see that. Huh?
Left side you will say.
Left side it gives the statistics like how many like what it does it, and then mainly what it is it has solved it. So it has been able to successfully solve it. In 2 iterations only it has been able to solve it. And so now if you see this code, what we are doing is we have defined that circuit, whatever circuit just now we discussed, and then we are asking you to set the mode to snapshot, algorithm is normal, and solve. So that's what we have done, right? So basically like these are the steps. So you define the circuit and then set the voltage basis and then do a calc to calculate the voltages, like you reset the voltages, the PUs and all that. Then you say okay, what is the mode and algorithm and solve. Okay. Now once you have solved it, so now if you look at it, so now mention that, so now you can view the voltages and so now you can view the voltages, currents, power, etc. So how do you do that? Like, so you can go here. So now if you see here, so you have voltage source and then you have line, you have the buses and all that. Right? So let us say we can go here and then you can select the so let us say like so you select the PD elements, and then in the PD element, let us say you go for a line, and then line 1 is there. So if you click on B, so it will show the voltages in that line, right? So what is this bus? What is the voltage? This is what is the voltage? So similarly, like if you say P, it will show what is the power. So it is showing it in like A plus JB, A plus
P plus J.
So this way you can see like, so if you want to see what is there on the load side, so that's a PC element, and then you can say load, and then there is only one load here, and then if you say B, so you will see what is the voltage here on that load. Okay. So this is if you want to explore. Now if you say no, I want to get the whole thing out, so you just say export voltages, and then you can tell what you want, right? So or show voltages, and then if you say all the voltages you want to see, so it will show all the voltages like source bus, and so what is the line and neutral voltages, angle, and the PU format, base case, everything is, you can get all the outputs. Right? So actually what it would have done is, if you, it would have created this CSV files here. Right? So it has, it uses the DSP format, and you can also export the voltages and into CSV file. So all those things it supports. Okay.
Sir, this is for basic load flow you are doing. Let us suppose that if I want to insert any distributed energy resource.
Yeah, we'll see. Yeah, so just want to first go steps, right?
So I think little slow because nobody's familiar with this.
Okay.
Once again, the please tell so that everybody.
Okay. So basic circuit. So if you look at the PDF, so this is the circuit. Okay. So this part, the circuit description you have understood, right? So this is the circuit we have taken, right? And this circuit is defined here. So base frequency is defined. Then the name of the circuit is simple. Okay. So you say, so here the format is element name dot the element type dot element name. That is the format. Okay. So here we are saying that we are defining a circuit called simple. and then it will by default create the voltage source for the circuit, and then we are defining the voltage source where we are giving the base kV and what is to start with, like the per unit, right, P 1.05, so automatically the voltage will be 1.05 into 115, right, like per unit it will apply, and then so you have the short circuit current, everything you define for this voltage source, right? And then you define this transformer. So now there are buses, two buses are there, source bus and the sub bus. Okay. So now you are defining the transformer. So it's a delta Y transformer. So you are saying, okay, transformer, the buses are source bus on this side, and the name of the transformer is TR1. Right? The TR1 is what is named as. So source bus and sub bus. And then what are the connections? You have defined the connections, delta on this side and Y on this side. And then the kVs. So 115 on this side, 115 kV and 12.47 kV on this side. And then the kVs is 20,000 kVs and XHF is the 10. So this is how you define the transformer. Now what are all available options? Like if you go to either the manual, right, so I showed you the two files, right. So either this tutorial cases, that also has got full description of all the options available, and the manual also has got the full description, right. So if I show you, like suppose if you go here, right, so if you go to the transformer definition, so transformer object, so it is a multi-terminal right power delivery element, and then it says, so what are all available, right? Properties are phases, so number of phases, default is 3, bindings, number of bindings, default is 2, and you define the binding, right? And then so for defining the binding, one binding at a time you have to define, and then you tell which bus you are connected, what is the connection, kV and all that, kVA, percentage R, so you can give the tab, percentage R, percentage resistance of this binding, right, R neutral, X neutral, so like this, you can give, what all parameters can be defined is explained here, okay, like hysteresis, thermal constants, everything, like, so about the transformer is mentioned here, fault rate, normal KVA, KVA, and so all those things are right. So you can also look into the the manual also, so there also the transformer will be defined, right, so there also, like if you go to the transformer element, so transformer code, like you can define the type of transformer and it shows like how to define transformer object. So what all parameters are there, right? Phases, bindings, binding bus, connection. So description of all the possible parameters you can view for the transformer. Okay. So they are all described in the user manual. So very detailed modeling they have done for all. these are all what you can define for the transformer. So like this it is there. So what? So here we are just given the basic definitions. And then the line code. So now this line is there. So for this line, first we have to mention what is the type for the line. So if you look at the definition for the line is there. Now again, if you look at the line code, what exactly that, how do you define, what is the definition for the line code?
Alright, next. Distance.
Yeah, so here is a full description of what is the line code, what is the object. So actually for that line you define the matrix. Right? The impedance matrix for the line is what is defined. So it has full description about how the line, how a wire is modeled. Right? So every wire, how it is modeled, and so you give the resistance matrix, and so that is how the line is modeled. Right? And then there are a lot of standard line models which are already available, which you can readily use. Okay. So this is how you can exactly control, exactly define whatever you want.
So when we are designing normal distributions like 33 or 69 or system small distributions, how we will know which type of conductor they are, because they have written 336 MSCR. So how we will know whether?
So you have to see
Type of
in that particular one what is the wire used,
Okay.
and for that wire you can get the model. So
Type of conductor.
the type of conductor, and like depending upon like how many cores, what is the size of each fiber, based on all that, all these parameters will be there, and I think you should be able to get the OpenDSS model for any standard wires. It should be available. So here like the line code is defined, and then after that we are defining a line called line 1. Right? So line 1, you say line dot line 1, and the two sides are there. Bus 1 is sub bus, bus 2 is load bus, and this is the line code which is defined here. So line code is that, and length is 1, units is miles. So that is how you define this line. And then you define this load. So load here what we want, we define the load as load dot load 1, and then what is the bus where it is connected to, that is load bus, and it is 12.47 kV and 1000 kilowatts and power factor 0.95. So with that the load is defined. If you can define a lot more about the load if needed, but this is a basic minimum definition. And then in this whole circuit we are saying there are two voltage bases. This side it is 115, this side it is 12.47, and then we are asking you to solve it. And so after copy paste, if you solve it, then it has solved it. Then you can look at the current, voltage, power, everything you can see in various parts of the circuit.
When we comment the transformer, right, sir, because that it is continuation, those two lines are continuation. Transformer dot TR1. And below line is both are continuation.
This field level is continuation.
Like math.
No. Normally if we comment it, code is not running.
No.
If we comment line and load, code is running.
No, so see,
If we remove in the diagram, if we remove the transformer, it is showing not solved.
so see,
If we remove line or load, it is giving the output. Is there any specific? The circuit diagram is there, that's it.
So okay.
If I remove the transformer,
Okay.
it is showing it's not solved.
Because you have to connect it, no? Like, so if you remove the transformer, then at least.
But line.
No. So if you want to remove the transformer, like if you want to connect these two lines, then what you do is this line one's bus, no? this bus one, you have to give it as this source bus, right? So you have to connect this one to the source bus, then the circuit will be complete. And then the circuit is open, right? So, is this clear? Right?
So what's the difference between MATLAB and this? Because MATLAB was like they do the same. So what's the difference between both?
So, one is MATLAB is a paid one, whereas this one is a free one. And so MATLAB, like speed, this is supposed to be much faster than any other system. This, like if you want to simulate circuits which has some 1 million nodes. And I will show you, like, so OpenDSS model is available for entire cities in US. Like the entire San Francisco city, the whole, every house, every pole, every wire, every transformer, the entire model is available for download in OpenDSS format for the entire city. So like that, so many cities in the US, they just publish the entire OpenDSS model. So you can just take that and you can just run it and retry it. So the entire San Francisco city, it has 330,000 houses. Okay, 330,000 houses. Then on top of that, there will be transformers, feeders, right? All those things. Then substation transformers, everything will be there on top of it. This whole thing he was able to solve in 22 seconds.
Same my power there,
Okay.
right? My power is a paid one.
So, like the OpenDSS is a standard format, so you can easily download circuits in various formats. So you know whatever you have installed now. So if you go to the folder where it is installed, right? So okay, if you go here and if you say OpenDSS, so now you can go and go for the file location. Okay, so you would have installed. Okay, here so I can go and. So it is installed in XC program file OpenDSS X64. So if you go here, so you can try this. See, you do this. I will tell you what to do. Okay. So if you go here and if you type in OpenDSS, right? So now this application is there. You do a right click there and you say open file location. Now this is just a link. Now if you go here and again like go to properties and then if you again say open file location, it will open the folder where it is installed, or you can directly go to the folder where it is installed. Now if you go one level up, then here you have documentation, right? And then you have the EPRI test circuits, and then you have IEEE test circuits.
All libraries are right.
So 13 bus, 34 bus, 37 bus, 123, 8005. So all these IEEE buses circuits are already given to you in OpenDSS format. So you can directly like take this and then you can open it, and then you can make whatever changes, you can run your simulations. So this is a very good set, like you can just go and explore. Yeah. So you can, so all these are available, right?
Maths model is there. Math model is also having all these things.
Right. And then it also has a lot of other examples like so you can go through it. If you go to the user manual, then you can see what all are available here. right? And then you can try it out.
The power system we can plan.
Which maybe they are using some network instead of that same way. Some activity we can do.
We can have a lab also. Let them explore, because in Iowa State University they use this. Then why not the university use? Should be there.
In San Francisco, they are using this software.
Maple they use now, instead of MATLAB, they use chemistry.
Okay, so and in the PDF I also given the water price. So if you want to see the voltages, show voltages, L nodes you can see, right? So you can, I give you instructions like what you want to select so that you can
She's
try
asking
it.
actually she told something now.
Okay. So, and then now if you see there is this in whatever I have given, right, snapshot, there is also one file called bus coords. So where you can give the coordinates of the various buses as x and y coordinates. So here it is given as like just 100. So basically like these are all points, okay, in the map. And then you can visualize. So in for a real circuit, this will be latitude longitudes. So if the latitude longitude is given, then you can actually see it on the map also. So it allows all that. Okay. So that is what is shown in this page. So this is a PDF which you already have, right? So how to plot the circuit. So which you already saw in the video also. So this part I will skip because this is just visualizing. So now we will go for time series. Okay. So either you can take the existing file, whatever you have, and whatever is changed is in red. You can do that, or the zip file I have given, in that there is a folder called time series. So there you can directly use the master. Okay. So let me close these two and click on this. So this is the circuit. First I'll explain the circuit. So now here the same circuit, right? We want to do time series simulation. So for that we have to first define a load shape. A load shape is basically what is the load versus time. And so here we are creating a load shape called daily profile. Number of points is 24. Interval is 1. So
Now what is the difference between this time?
So the previous one was snapshot. Just in one, we just solving a circuit.
One instant.
This one is like it is the series, right? It's a time series. Here we are creating 24 hour load. You can create 24 hour. You can create for 1 year also. So you can have
Continuous data.
continuous data, and then you can run the whole thing, right? So this is why we are creating a 24 hour load, and this is one way of doing it. So where you can mention here only as the value, and these are all in PU, like per unit. Okay, so this will get multiplied with, so it is on base of 1, right? So per unit values you mentioned here. So then you have, this is how we define a shape. Then in the load, whatever we had done before, we have created a load of 1000 kilowatts, where you mention this profile, the day profile, you say this. Then for throughout the day, it will multiply this 1000 with this number to define what is the load at that particular time. Okay. So this is a multiplicative factor.
So the 1000 is base load or is?
That's the base. Base is that there is a So in case of snapshot, that is the actual load.
Okay.
But when you put it for a daily profile, there is a multiplier. So you have here the actual curve, and this is the multiplier with which you want to multiply.
Actually is equal to per unit into base. Formula of the sir, per unit is equal to actual into base.
So
This 1000 is, yeah.
so this 1000 will be multiplied. So say if you look at this, so at the first, so this is all 1 hour, right? So at midnight or at 1 o'clock in the morning, it is 800, then 700, then 600, 600, 7, 900, 1000, 1100, 1200. So this is how, right? So it just it's a multiplier. And then we can add monitor, like to see how things are, monitor. And now again, if you look at the document, you can see now we define the monitor. One monitor name is load 1, and load 1 VI, that is what we have defined, and put it on load 1 terminal 1. So load of course has only one terminal. If you put the monitor on a transformer and all, then you can have terminal 1, terminal 2. Right? Similarly, if you put on a wire also, terminal 1, terminal 2. Now, if the transformer has multiple coils, secondary side coils, then you have still more terminals. Each coil will be 1 terminal. Okay. So here for load, it is 1 terminal. So we say terminal 1. Now this mode 0 means voltage and current. Mode 1 means real and reactive power. Okay. So that definitions, like if you is there in the tutorial, or like if you see here, like you can have the definitions. So now so if you look at the load or outside monitor. Yeah, so monitor, if you see, the mode is there. So mode 0 means voltage and current for each phase. Mode 1 is power on each phase, right? Complex, so kilowatt and kilowatt hours. Mode 2 is transformer tabs. Mode 3 is state variables. Like, so like multiple modes are there, but basic modes are 0 and 1. Okay. So what are we doing here? Like, so we are looking at the mode 0, we are defining one monitor, and mode 1 we are defining another monitor for load 1 PQ. So 2 monitors are defined, and then mode, the simulation mode, we set it as daily. It can be daily or yearly, so you can set it. So here, because we are giving a daily one, we are saying daily, and number of points, number of steps we want to simulate is 24 steps, and step size is 1 hour. So all these things we can mention it here, and then we can run it. So after running, we can view the voltage power on the monitors. So you can plot the load shape and monitor. So let us try that. So how do we run it? Same thing, Control A, Control D. Now it has done it. So now first we can see the load shape, right? So yeah, so load shape, there is one load shape here. Right? So if you want to plot load shapes. So this is the load shape which is there, right? Which we have defined, and this is in per unit. Like whatever we saw there, like the same thing. And then we can plot the monitors, right? So we can plot the monitor. So there are two monitors here. So the voltage and current monitor. So we can monitor, we can plot voltage, current, all that. So if you so this So this is the voltage, how the voltage varies over time. So like this, we can plot. So, and you can run, if you, yeah, we will see, like, then maybe start putting PV, then we will see much more interesting.
For one bus system, you have considered the 24-hour load, sir. For one load. Let us suppose that I have 50 bus system. Normally in MATLAB we will create one loop and we will give based on that it will multiply it. In this case what we will do? So let us suppose 5 loads are there.
So you can either take this load shape and apply
Again copy again like or
no, you can just define only the load.
okay.
So for the load you can say yes, okay, you apply this to all the loads, or if it's already defined, you can say for all these loads apply this load shape.
Okay.
So you will
Okay.
So
Don't try to open down directly it will.
directly. Fine. So this is the time series simulation, right? So now is it okay? Like, so time series is clear, right? After doing it, then I'll come back and I'll show you on Python. Okay. So after so this is time series, and then so I have given it the PDF like what you can do. Okay. So now if you want to simulate.
What was this?
After that,
Load shift, anything, whatever.
Okay, I completed. Okay. So now
because here the Python.
Now to simulate wind and solar, right? So either you can create using generator only, or it also has specific wind gen, solar PV system, and battery storage. All those models are also available. So if you want to use, for example, like using the generator, like you can define a load shape, and then you can give it as a generator, right? So you can do it that way. So we will look at an example where we will do a PV simulation, right? So this is how you do, like, so we have this load shape, like, so you can create a new load shape where you can give the number of points. So here, for example, like we are saying, so there is a file PV shape 24 hours 1 minute, right? So if you look at the file which are given, so there is a PV shape 24 hours 1 minute, and there is also a wind shape which you can use for testing PV and wind. So if you look at this, right, like you can open it in a, so if you take this and plot it, right? Right, so this is the PV shape which of the input file which is given, right? So at 6 o'clock it starts generating, and at 6 o'clock it finishes. So this is the number of points, right? So this is what is the 24 hours 1 minute interval, right? So this file is there. This is the PV file, the CSV file. So we will use this file and we will generate. So if you So basically if you do this, so we have, it's the same thing whatever we have done before. So here what we have done is we have defined the PV, the load shape is defined, number of points is 1440, 1 minute interval, right, m interval, and this is the name of the file. So this is how you define where your load shape is given in a CSV file. So you define the CSV file and then normalize it, so it will basically normalize it between 0 to 1, which you can apply for your PV gen. So you have a PV system here connected to the load bus and 12.4, so whatever the kV of the load, and then it's a 10 kilowatt PV system power factor 1. So and then here you are defining daily equal to PV. So whatever we define the load shape here, we are giving that. So now we have connected a PV to the system. So whatever we saw earlier, right? So what we are doing, so the circuit whichever was here, to this load bus we are connecting one PV. Right? On this side we are connecting one PV. That is what we are doing here, right? So basically, like if you see here, the bus is load bus and it's a 10 kilowatt power factor 1 with this PV shape, then it automatically becomes a generator which is connected to that. So once you are connected, then we are adding load monitors. We'll add one monitor to the load and one to the PV and one to the transformer, and then we can see what happens. So we are doing a simulation, right? So if you do that, so you do a control A, control D, just done the simulation, and then plot monitor. So we have the load. So the load side is still the same, right? Like so we saw what we have created, the original load, that is the same. And then the PV, how does a PV generate? So if you look at it, so this is a estimate for 12 hours, so it gives the 12 hour for this. Yeah, okay. Number of
24.
steps is only 12. Okay, if you put it 24, then so we can let's say you have the 24 part, and then you can plot the monitor on the transformer side. So we saw the solar is generating and then the load is also there. So subtracting that, then that is the load on the transformer you can see. So this is how you can simulate. So this is how you can simulate, and you can also export the as a CSV, the time series, all those things we can. So now what I'll do is like how do you interface it with Python? Okay. So I'll show you that. So any questions so far? Is it clear? Is it clear or is it too fast? So shall we go to the Python?
Not clear. PV part you tell 7
Okay. So basically like you define the circuit, right? And so this is how you define the solar, right? So you define a load shape, right? So we are saying here number of points is 1440. Why is 1440? Because we are giving it every minute. So 24 hours, right? So every minute, so 60 into 24, right? So that many points we give, and that we mentioning it in a CSV file. So how does the CSV file look like? So if it is for the PV, right? So this file is already given to you. Already given it in that. So if you look at the, I'm just opening it in Excel, okay, and I'm just plotting it so that you can see how it looks like. So this is the typical solar curve, right? So this is one full day. So at 6 a.m. during midnight, no production. 6 a.m. the production starts, and then this curve is there, peaking at 12 noon, and then it comes down at 6 p.m. it stops. So this is the typical solar curve, right? Now this curve, we feed it as the input to the circuit. Saying, okay, this is the production, and this is the solar curve, and then we create a generator called PV connected to the load bus, right? So if we see in our circuit we saw, so this is a circuit, so we are connecting a solar generator to this point, right? To the load bus, we are connecting the solar, so bus on this load bus, and we are defining it as a generator. So generator means like the power will be pumping into the system. Load is, so the positive negative it will automatically, it will cancel. And then the bus voltage is 12.4, so we are just mentioning that only. And then we are defining what is the capacity of the solar. We are saying it is a 10 kV, 10 kilowatts solar, right? And power factor is 1 because it is solar. And these are standard connection generator, like standard things you have defined. And then you say like what is the curve for this? You say PV is the curve. So load shape PV is there, so you automatically use that. And model basically you can like use the same thing. So again, if you go to the generator, there are various generator models which are there, right? So we are using the basic model 1. So we have defined the solar PV generator here. And then we are defining monitors so that we can note down what is happening. So monitor will always take, after the whole simulation is over, you can ask the monitor, you tell me like over time what happened, right? So monitor is over a time series. So we define the monitors and which points you want to measure, we are putting in. So we are putting it one at the load, one at the PV, and one at the transformers terminal 2. So what is it? So if you look at this, so one we are putting it on the load itself, another monitor on the PV, another monitor on the transformers secondary, that is terminal 2, we are putting one monitor there. So that we can see how this adds together and appears here. So that is what we are seeing here, right? So you put the monitors, and then we are saying mode is daily, and number of steps is 24, step size is 1 hour. So even though we have given this as 1 minute, for the load we have given only 1 hour. So we are, if you don't give, even if you put it as, then it will automatically interpolate and it will do it. But then we are saying, okay, you compute only for 24 hours, 1 hour steps, 24 hours, and then we are solving it. And then if you visualize, then you are seeing, this is how the load is, this is how the solar is. When you put everything together, this is how it appears. Right? So this is how you can see. Is it clear? Is it clear or? Right? Yeah, so basically just if you try it out, right, you can, the PDF you have, so you can copy paste and then you can, and the files also are given, so you can directly run it, then you can find how it is. So how to do it in Python? So Python has got, like for OpenDSS there are so many libraries in Python. So after trying so many things, I found this was the simplest one. There is a library called this OpenDSS Direct. Okay. So I have given the pip commands for installing it. So if you install that, then you will have this. Okay. So let me show you. Okay, there. So let us look at this Python script. This is a basic one. So what are we doing? We are importing the libraries, right? And so and then here we are the usage we are defining as Python run dss.py and then path to the DSS file. So any DSS file you give, we can run using this Python script. Okay. And we are running the DSS file, whatever is given there. And how do you do that? Like you do clear and then redirect, and then we are doing export voltages. So this is what we are doing in this Python script. Okay. So if you look at the files that I have given, so if you go to snapshot, there is a run dss.py, right? You are with me? Right? So the run dss.py, if you see what is there in this, it is exactly what is there in the PDF, right? So this is all that you need. Okay. So whatever we are basically, we have to view for run dss.py, then give the path to DSS file as a parameter. So what do? We just go here, copy the folder and CD to that. So now here that file is the master.dss. That is what we saw, right? So run dss master.dss. Run correctly. So if you look at the file, right, so we have asked it to generate this voltages, right? So that's what we asked it to do, right? So if you look at the file, so we have asked it to we have said export voltages, right? So we are so master.dss only we have given the solve also, right? Or you can, so sometimes what you can do is if you look at the yeah, so see you have this master.dss, right? So we have put the solve in the master.dss itself. So when you say redirect, give the DSS file, it will solve, it will run the whole thing. So it has already solved. So then we say export voltages. So all voltages we are asking you to export. So that is why we have that. It has created this. So the circuit name export voltages, this file is created. So any of you have Python working on your system? You can try it. Yeah, I'll go through it. So this is a grid modernization.
This is for both power system and power grids, both we can
So this is the basic Python script, okay, to run any DSS file. Right? So this command called redirect is there. You can see redirect and you can mention any DSS file. So just like running it within Python instead of running it on the email. So one thing is, suppose let us say like you have what line. You are defining your load, just like what she said. You are defining your load. And then you say, okay, like I am defining one load 1 with this for bus 1. So I want to add 100 loads, load 2 for bus 2, load 3 for bus 3. So you want to, so instead of putting 100 lines, you can put a Python loop. You can put a Python loop and then you can construct that command as a string within Python and then you can run it here. So you can do those kind of optimizations. Or if you say like I want to add PV to all the loads, you can put it in a loop, right? So those kind of advantages, like instead of repeating it, you can put it in this. So that is the advantage. Second thing is after running the simulation, you want to extract the data and you want to visualize it. Now by running it within Python, you can use all the Python facilities to visualize it. Okay. So that is the advantage. So here, so there is this command called text.command where you can give any DSS command as you give it and it will run. Okay. So here what you are doing, it is saying clear and then whatever already existing DSS file, if you want to run, you say redirect. Then it will run that entire file. After that you can run whatever DSS command you want. So here we are running one command called export voltages. So this way, so this file you have given it as master.dss, so this is the old file whichever we created. So it runs this whole thing, solve is also there. Otherwise you can put solve outside. So if you want to do only the circuit definition as one file and solve you can do it separately. And then when you do export voltages, it generates a CSV file like this. So this is a proper CSV file which you can again take it into Python, you can do whatever you want also. So this way you can do. So this is the basic Python usage, right, which I have given it here. Now same thing you can do to the time series, right? I will show you time series when you run it from within Python. Okay, this is a snapshot. So these folders also I have given you already. All these folders are there. So in time series you have this plot.py. So here if you see here, so we are using the time series. So the time series master.dss we have, right? So in that we already have that monitors. So here we are taking this load1.pq, that monitor, and then we are loading that monitor as a matrix, right? And then with that matrix we can plot it. So that is the advantage of putting it in Python. So we saw that we saw the time series, right? And then okay, what is it? Sorry. So this master.dss we wrote for when we wanted to do for this time series, right? Like where we simulated this load, and then there we saw this created two monitors for VA and PQ. So this is the OpenDSS file which we already saw. What we are doing here is we are running that file, right, from within Python, and then we are solving it, and then we are accessing the monitors from outside. So you can, all the circuit elements, solutions, everything you can access from outside from Python also. So from Python we are accessing the monitor named load1pq. So load1pq we saw here, this load1pq. So we are loading that into Python, and we are loading that result as a matrix. And once you have it as a Python matrix, then we can plot using standard Python. So this is what, let us see how it works, right? So Python, and so this is the plot.dss, right? So it does the Python plot, right? So this way you can integrate. So you can use Python for your visualization and processing the output. So what you do is the code simulation you use OpenDSS, and then after that you use Python for all your analysis everything. So that way you can mix both. Right? And so if you see here, like all this hourly power, this kilowatt, hours, so everything is actually defined in Python, right? So you are saying X label is hours, Y label is kilowatts, title is hourly power, show the legend. So all those things we put there. So automatically, like, you can use your standard Python matplotlib for everything. This is one example. So this is there. And third example. So all these files are already given to you. Okay. So this PV is there. Under PV you can see there is a plot dss.py. Let us see what is there in that. So here what do? We run the PV simulation one, and then after that we take this load PQ, load side monitor, PV monitor, transformer monitor, and then we plot all of them together into one. So we can try it out. So that was open in the Excel, so Excel was not allowing Python, allowing OpenDSS to open it. So you can see here, like, what is the effect of PV. So this is load 1. So this is the load, and then this is the PV, and then this is the transformer. So how it works, right? So like this you can create. So this kind of thing you cannot do it directly with only OpenDSS, like putting multiple graphs together and showing it, and changing the color and changing the line type. So all those things Python does it best. So by combining both, then you can get both the best of both.
Publication. We are
So this is a simple way to run OpenDSS from within.
database details.
Okay, so all these files, all the folders are given to you, so you can directly take it, you can modify it, you can try things. And yeah, so this is what I showed you already. Yeah, and OpenDSS has got this batch edit and all, like you can explore those. Okay, so this is the recommended project structure. Okay, so if you get so this is the recommended project structure. Like if you're having a big project, even if you go and download huge projects, you can find that they are already organized in this format. So you have that project at the top level, then you have the run scenario, like various scenarios you want to run, and then you have a folder for meters, bus coordinates, load shapes, reports, so where you generate the reports into that. Then you have a circuit folder where you define your circuit, substation, feeder, like so that way, like, and then you have your all your definitions, right? So this is how it will be there. And advantage of OpenDSS is open source, supported by EPRI, and a lot of sample circuits available. And so here are, so this is the one which I told you, like lot of US cities, sections in different places. The entire OpenDSS model is available. And IEEE circuits, EPRI circuits, so they are all available. Tutorials, everything is there. And if you search on the net, you can find a lot of derivative works also based on OpenDSS. And so here there is this is from Panda Power. So Panda Power website has a nice comparison chart with other various simulators. And of course Panda Power has everything picked, and the other one is OpenDSS here, like, which has got almost everything. Okay. And so the difference between OpenDSS and Panda Power, the advantage of OpenDSS is speed, right? That is what they mentioned, right? And whereas additional features are there in Panda Power. So when you look at the open source ones, I think these two are the best competitors. Yeah, so that's the end of what I have. Any questions? So here this is only the introduction. So all the PDFs are with you, all the code is also with you. So you can take it, you can try it, run it out, modify it. So you can. Any questions, comments?
Since you have shown the snapshot and series the codes that is a standard format. It's like initially it will start with defining the circuit, then no
Yes. That's a standard format. So the tutorials, actually those also I copied from the tutorial. So tutorial and then modified it.
Okay. Depending upon our requirement, we can.
Yes. And most of the time, like instead of starting from the scratch, you will take IEEE 123 circuit and then you will modify. So those circuits are already available in OpenDSS format. When you install OpenDSS, only it is there. Right? So in the folder where it is OpenDSS installed, if you go there, the sample circuits are all there, which you can use as a sample.
Who will use those circuits?
Any other questions?
On behalf of the Department of EEE, we would like to sincerely thank our resource persons for delivering such an insightful and engaging session on research problems related to smart meters, distributed energy resources and electric vehicles. In the formal session, your detailed explanation of the key challenges in these domains, along with the discussion of emerging technologies and practical solution approaches provided us with valuable clarity and direction. In the afternoon session, the hands-on session with OpenDSS software was extremely beneficial. It gave us practical exposure to modeling and analysis techniques, helping us better understanding of system behavior, integration challenges, and simulation-based evaluation method. We truly appreciate the time, effort, and the expertise you shared with us. Thank you, sir. Now I would like to invite the head of the department to hand over the memento to the resource person as a token of appreciation.
So any feedback on what could be better? Like, so are you able to follow through, like for the pace and depth, breadth, everything? Okay. Let me know in case any feedback you can tell ma'am and she'll get back to me.
ಸ್ವಲ್ಪ ಹಿಂದೆ ನಾನು ನೀವು ಬಂದಿಲ್ಲ ಮುಂದೆ ಮುಂದೆ ಬಂದಿದೆ